10th CBSE Chemistry, Chapter Periodic Classification of Elements. In this video, you're going to learn about the trends in the periodic table, the periods and the group, valency and electronic configuration, alkali metals, noble gases, halogens, metals, nonmetals, and metalloids. Observe carefully. What you're seeing on the screen is the modern periodic table. This table has 118 elements. The table has elements which are arranged in an increasing order of atomic number. This we already know, that the modern periodic table is based on the atomic number. But there's one small question which pops up in mind when we observe and study the periodic table. Why is periodic table given so much importance? Why is it considered as one of the outstanding works in chemistry? Why are scientists so crazy about periodic table? Well, this question becomes important because all the matter in the world, what we are observing around us, is made up of some kind of elements. And all the elements which are out there in the nature are brought and listed in this table. There are many other reasons because of which periodic table becomes one of the outstanding works of chemistry. Now let's study the periodic table to understand its importance. Observe carefully. The periodic table is very colorful, right? You see hydrogen with green color, okay? You see yellow color, pink, red, blue, all these colors in the periodic table. You also see the alphabets, right? H, L, I, N, A, K. So what are all this? To understand what is the information given in the periodic table, let's consider the first element which is listed in the table, that is hydrogen. So the first element listed in the table is hydrogen. You can see the symbol of hydrogen as H. Below that you can see the name of the element which is written hydrogen, and below that you can see a number. It's 1.008. Now this is the mass number of the element, that is hydrogen mass number. And on the top you can see number 1. This is the atomic number of the element. Moving on, we see helium, atomic number 2. It has symbol He. We can see the element name helium and its mass number, which is 4.003. Now this is the same for other elements, continued with lithium, beryllium, boron, carbon, and so on. So when we observe the periodic table, this is the basic information we get about the elements. We get to know the element, its symbol, its atomic number, and mass number. Some periodic tables also give more information about the melting points and boiling points of the elements. The periodic table has rows and columns. You can see that there are 7 rows. 1, 2, 3, 4, 5, 6 and 7. Now you may think that this and this is a separate row, but that's not true. These 2 rows fit into these 2 rows. Okay, it's been just separated from here and kept outside the periodic table. And I'll explain you in a while why it has been kept like that. So there are 7 rows in the periodic table, and rows of periodic table are given special names as periods. So there are 7 periods in the modern periodic table. Now let's examine the columns. So this is the first column, 1, 2, 3, 4 up to 18. So it goes up to 18 columns. So in the modern periodic table, we see 18 columns which are called as groups. Columns are called groups and rows are called periods. So the modern periodic table has 7 periods and 18 groups. The arrangement of elements in this periodic table is very specific, and we know that it depends on the atomic number. Moving on, there are other specialities of the periodic table when we consider the different rows and columns. Now observe here the first group with hydrogens as a starting element. You can see that hydrogen is in a different color. It's It's been colored in green, whereas the other elements in the group are colored in red. Now, is there any special significance for this? Yes, it is. Except hydrogen, all the other elements in the first group are alkali metals. Alkali metals are the special kind of metals with the valency 1. Down this group, we can see that all these elements, lithium, sodium, potassium and others, have the same valence electron, that is 1. So with the valency 1, all these elements are highly reactive. That is the reason we do not find them in the free state in nature. Moving on the other end of the periodic table, we do find the list of noble gases, or they are also called as inert gases. Starting from helium, all these elements are gaseous in state and they do not react with any other element easily. It's because of their valency again. So you see that they have the completely filled outer orbital with 8 electrons. There is one thing you should observe here. When I talk about the valency and the electronic configuration of the elements in the periodic table, we do see that there is a similarity in the valence electrons down the group. Like for example, if you take the first group, all the elements in the first group have valency 1. It means that they have one electron which is ready for bond formation. In the same way, all the other groups show the similarity in their valence electron. Further, you have one more group called halogen group, group 17, where you find fluorine, chlorine, bromine, iodine and others. Now this is a special group of elements which are called as halogens and are highly reactive in nature, just like the alkali metals. If we observe the valency of the elements, all these elements have valency 7. So they need only one more electron to obtain the electronic configuration of a noble gas and hence are highly reactive. Halogens are also called as salt formers because when they react with the other metals, they do form salts. The periodic table divides the elements into metals and non-metals. The elements which are placed diagonally in the periodic table, that is boron, silicon, germanium, arsenic, antimony, tellurium and polonium. So all these elements which are diagonally placed in the periodic table divide the periodic table into metals and non-metals. On the left side of this diagonal, you find all metals. And on the right side, you find non-metals. See the difference between the metals and non-metals, their number. You see that majority of the elements which we find in the nature are metals, whereas there are only few non-metal elements in nature. What about these elements which are placed diagonally in the periodic table? Are they metals or non-metals? They are metalloids. It means that they simply possess the properties of both metals and non-metals and hence are called as metalloids. The properties in between of metal and non-metals. Now let's do a quick recap. Modern periodic law states that the properties of elements are the periodic function of their atomic number. We learned the rows in the table are called periods and the columns groups. The modern periodic table is made up of 7 periods and 18 groups. And also the first group has hydrogen and alkali metals, group 17 has halogens, group 18 has noble gases. We learned that the valency of elements down the group is always same and we saw the examples for that. In this video, we covered the trends in the periodic table, that's the periods and groups, valency and electronic configuration. We also studied the properties of alkali metals, noble gases, halogens, metals, non-metals and metalloids.